Look at this mechanical apparatus. This is your baseline. It represents a complex AI application built on a specific locked-in language model, like GPT 5.4. Everything in the system runs in perfect rhythm. Fast forward 30 days. Users suddenly start reporting a breakdown. Your agent is hallucinating tools that do not exist, JSON payloads are malformed, and the entire system cascades into failure. You run an emergency audit on the codebase. You check the Git commits, the server logs, the environment variables. The infrastructure is flawless. Not a single line of your application code has changed. The culprit is entirely outside your servers. The cloud provider issued a minor, unannounced version update to the underlying language model itself. When you build applications on top of cloud-based neural networks, your software's core logic can shift overnight without your permission or warning. We call these silent regressions, the invisible drifts in how an AI model formats its outputs, utilizes external tools, or applies internal reasoning steps. In traditional software engineering, developers rely on absolute mathematical certainty. If a package updates, you run a line-by-line diff to see the exact variables that changed, clearly highlighted on your screen. You cannot run a standard line-by-line diff on a neural network. If you prompt a model twice, the exact vocabulary will change both times, even if the strict meaning of the answer remains the same. This diagram illustrates the measurement vacuum. Traditional testing is useless here because we have lacked a mathematical mechanism to measure semantic drift, the actual vibe and meaning of a black box, before deploying it to users. An open-source tool called LLM-Behavior-Diff was built specifically to solve this measurement gap. It acts as a forensic instrument for AI behavior. A single test probe is forked into two parallel realities, Model A, the old version, and Model B, the update. These probes act as stress tests, presenting complex coding problems or safety constraints to see exactly where the reasoning bends. Layer 1 calculates exact word-for-word overlap. If models output yes and affirmative, it fails. Layer 2 rescues this using sentence embeddings, converting text into 3D spatial coordinates. By calculating physical distance between these points, we mathematically prove two different strings share identical meaning. This measurement prevents false alarms. It provides developers with concrete proof that a model's core logic remains intact, even when its vocabulary changes. Embeddings easily capture basic semantic meaning, but they struggle to reliably track complex, multi-step reasoning or nuanced shifts in tone. That brings us to Layer 3, the LLM as judge. The tool invokes an external, high-reasoning model to act as an independent, third-party referee. This judge analyzes both parallel outputs. It identifies superficial differences, like verbosity, and confirms if the core reasoning path survived the update. Behavioral diffing requires advanced AI to verify AI, creating an automated peer review system for reasoning style. Watch how these chaotic data streams converge. The tool collapses all three layers of scoring into a concrete HTML report, categorizing the drift into actionable, minor, moderate, or major severity buckets. Developers insert this probe suite directly into their continuous integration pipelines, or run it through an MCP server. It acts as an automatic quality gate before a model swap touches the production environment. Instead of waking up to a failure cascade triggered by an unannounced model update, your engineering team receives a flagged report holding the deployment back. By quantifying these shifts, it allows developers to treat model updates as manageable software dependencies rather than unpredictable events. Like the conductor in this video, the modern software engineer is shifting roles. The job requires moving towards orchestrating and auditing probabilistic behavior. To build reliable software in the age of generative AI, testing your code is no longer sufficient. You must possess the tools to mathematically interrogate the AI's mind.